Today you will be doing as usual first the revision, brief revision, and then the properties of cathode rays. Short topic. So what we have done, what have we done? We have started chapter number 3, delta element theory and the modern atomic theory. Both of these went side by side. According to delta element theory, everything is made up of indivisible, indestructible particles called atoms. According to the modern theory, I am revising it in a comparative form. Okay? So, according to modern theory, atom can be divided. It has electrons, protons, and neutrons, as you can see on the screen. And atoms of the same element are identical in shape. Understood? Atoms of different elements, like if we have a piece of gold and a piece of silver, then the atoms of gold will be different from the atoms of silver. This is according to delta atomic theory. Today we know that there are the atoms of the same element which differ in their masses. Okay, which differ in their masses. We call that property what? Isotopes. We'll study in detail after in this chapter. Okay, then there are the other points. Atoms combine in simple ratio. This was in accordance with the Dalton theory, but the modern theory says today they may combine in complex form, like carbohydrates, proteins. All of these are complex molecules. Okay, what else? Matter atoms can't be created nor be destroyed. We know that in nuclear reaction, a part of matter is converted into what? Into energy. So matter can be destroyed, but conditionally. Not in chemical reactions, but in nuclear reactions. So this was a little brief revision about the delta atomic theory and the modern atomic theory. What else we did? One more thing that I would like to share with you, that symbols, we know that the symbol of hydrogen is H, this we know today. Carbon is C, gold is AU, and silver is AG, etc. But before these systematic symbols, Dalton proposed such type of symbols. Like for carbon, a circle, which should, like hydrogen, a dot in the circle, and so on. Later on, all of these have been changed by our regular symbols. Okay? Then we have studied this topic. What is this topic? What was that? There is a topic which is related to all of these things: the tube light, the neon signs, the CRT, cathode ray tube, the screen, computer screen. All of these are related with this topic, the discovery of electron. What was done in this experiment? In Crookes tube, what J.J. Thomson did, he took a glass tube and he fitted two metallic rods, or you can say two metallic plates rather, inside the tube, one on the left and one on the right. One of the plates is connected with the positive side of the battery, this is called anode, and the other one is connected with the negative side, this is called cathode. And he also connected a vacuum pump. Right? So when he decreased the pressure by starting the vacuum pump, he was able to evacuate the tube. Then at that stage, what happened? He found that certain rays are creating from cathode and traveling towards anode. Okay? A bluish green radiations or rays rather was there inside the tube. And later on it was came to know that these rays are electrons. These rays, the cathode rays, are made up of electrons. So in this way, the first particle of atom was discovered. What was the first particle? Electron. So electron was discovered by J.J. Thomson by discharge tube experiment, by Crookes tube experiment. All right. And here is Mr. J. Thompson, who got Nobel Prize for this discovery. Today, what is the topic? Today we'll see that what are the properties of cathode rays. All right. So, which is the first property over here? These rays travel in straight lines. Suppose this is cathode, this is anode. Then they travel like this in a straight line. And when they travel in a straight line, they may form shadow. Our shadows are formed by sun because we interfere, means the objects interfere. When the objects interfere the sunlight, the shadow of the object will form. Similarly, since these rays travel in a straight line, if we keep an object in their path, what will happen? Its shadow will form. So what is the first point? These rays travel in straight lines because they form shadows. Okay, second point. What would be the second point? These are, suppose this is the tube. Here we have cathode. This is connected with the battery. And here we have an anode. This is connected. These rays are traveling towards anode. Means they are being attracted towards anode. It means they themselves are negatively charged. These rays are negatively charged. It means they have possess of power that we call negative. So what is the second point? These rays are negatively charged. Why? Because they are moving towards the positive plate. The positive plate, the anode. They are being attracted towards this one. They are trying to go over there. So which is the first point? These rays travel in straight lines. Why? Because they form shadows when an object is kept in their path. Second point. These rays are negatively charged. Why? Because they are being attracted, they are going towards the positive side. Okay, it means they are negatively charged because they are going towards the positive side. As we know that plus and minus, they always attract each other. Okay? Clear? Which is the third point. As these rays are composed of electrons, suppose on a windy, stormy day, what do we feel? We feel particles of sand, dust on our face. Why? Because these particles, these sand particles, these dust particles are material, so we feel it. Similarly, these rays are material particles, so when we keep something which can rotate, they are able to rotate it. Okay? Suppose these are cathode rays, and this is something rotated by a paddle fan. So when it hits it will start rotating like this. Means these rays possess an energy. This energy is called kinetic energy. What is kinetic energy? Energy possessed by the moving object. If I am moving, it means I am possessing kinetic energy. So these rays are in motion, means these rays are possessing what? Kinetic energy. That is why they are able to transfer their energy to the object which can move. And as you will see afterwards, these objects are able to will move when cathode rays hit them. Okay? So this is another point. Which is the first point? They travel in a straight line. Why? Because they form shadows. Which is the second point? Which is the second point? They are negative charge because they are moving towards the positive side. What's the third point? They can rotate a little pedal pen because they possess power. What kind of power? Kinetic energy. Alright? Similarly, if a metallic object is kept in their path, then the metallic object will become hotter. Alright? It becomes hot because kinetic energy will be converted into heat energy. They have a charge, they have a mass which is constant. So we say that their charge to mass is constant. And the most important thing is there isn't any matter in the universe that we have discovered, the scientists, which doesn't contain electron. Each and every type of matter contains electron. That's why we say that electrons are the fundamental particles of each and everything. Okay? Now let's see a few videos. Here you can see what? You can see cathode rays are producing the same arrangement is here. It's just an animation. Alright? These are the cathode rays like this, a tube in which you can see two electrodes are there. Now, if we apply a magnetic field over here or an electric field, what will happen? They will bend. You can see right now the shadow is forming because these rays are traveling in a straight line. These rays are traveling in a straight line. Now the shadow, here we have brought batteries, one on the left, one on the right. So these rays are bending towards the positive side, which clearly indicates that they are negatively charged. Similarly, if we bring magnet, then they also bend. As you can see right now, they will bend. So we can say that these rays can be bent in an electric field or in a magnetic field. Now see something over here. Here's the real one. A dark room in which
cathode rays are produced in a discharge tube. A vacuum pump is used to evacuate the discharge tube. The cathode of the tube is connected to the negative terminal of the battery, and the anode of the tube is connected to the positive terminal. Allow the current to pass through it. However, when the pressure of the tube was reduced to 0.001 mm Hg, and a high potential difference between 10 kV and 20 kV was applied, at the end of the tube, a glow was seen on the walls of glass tube. The rays emitted by the cathode travel towards anode. The attraction of rays towards anode reveals that the rays carry negative charge. Properties of cathode rays are: 1. When any object is placed in the path of the cathode rays, these rays cast shadows. This shows that cathode rays travel in straight line. 2. When a wheel was placed in the path of cathode rays, the wheel rotates. This shows that rays consist of some particle and some kinetic energy. 3. In the presence of an electric field, the rays are deflected towards the positive plate. This confirms that cathode rays consist of negatively charged particles. 4. In the presence of a magnetic field, the rays are deflected. This shows that the cathode rays are affected by the magnetic field.
So, dear students, these are the properties. Which is the first property? Let's find out the topic. They travel in a straight line. Which is the second one? They can rotate a wheel. because they are having a power, kinetic energy. They produce fluorescence. This we have discussed earlier. That these rays when hit with a wall having a coat of zinc sulfide, these rays will glow, will produce fluorescence. All right. These rays are negative charge. We have done. Let's see the final one. You can see a real video over here, a very short video. In dark room, you can see cathode rays are emitting out.
Partial vacuum, and a little glass wheel.
What's what?
It's free to rotate on a little axle. And so what Crooks did, turned it on.
Cathode rays are producing, and this will rotate the wheel in real.
There we go. Okay, and you notice.
You just realised, Mark?
So what is the homework assignment? Briefly explain discharge tube experiment with the help of headings and also mention its properties. You will submit this assignment on Google Classroom. The assignment will be uploaded after about a few hours. What will we study next? Discovery of protons. That's all for today. If you have any question, you can ask in the group or you can ask individually. Thank you so much. Take care.